Today, we'll be demonstrating how to accurately read a potentiometer using a multimeter in voltage mode. First, ensure your multimeter is set to measure DC voltage. Connect the red positive probe to the middle terminal of the potentiometer, which acts as the wiper. Attach the black negative probe to the ground pin. As you slowly turn the potentiometer knob, observe the display on the multimeter. You'll notice a change in voltage as the resistance between the wiper and ground increases or decreases, allowing you to confirm the potentiometer's functionality and the accurate measurement of voltage. As you adjust the potentiometer, the multimeter's display will show a gradual increase or decrease in voltage, confirming the potentiometer's ability to control voltage output smoothly and accurately. Let's discuss how to integrate the LM35 temperature sensor with an Arduino board to monitor the operating environment of your project. The LM35 is a precision temperature sensor that provides a linear output directly proportional to the temperature in Celsius. To begin, connect the VCC pin of the LM35 to the 5V pin on the Arduino, the ground pin to the GND on the board, and the analog output pin to an analog input, such as A0. Using the Arduino IDE, you can write a simple sketch to read the sensor values. The LM35 outputs 10 MV per degree Celsius, so by reading the analog input and applying the appropriate conversion factor, you can monitor the ambient temperature in real time. This setup allows your project to track environmental conditions, which is essential for projects sensitive to temperature changes or those that require real-time monitoring of operating conditions. As the Arduino reads the output from the LM35 sensor, you'll see real-time temperature values displayed either in the serial monitor or on an external display, depending on your setup. The sensor provides an accurate measurement of the ambient temperature, allowing you to monitor environmental conditions with precision. This data can be used to trigger automated responses in your project, such as adjusting cooling systems or sending alerts if the temperature exceeds a specified range. Overall, the LM35 offers a reliable solution for temperature monitoring in a variety of applications. In this project, we will demonstrate how to use an RGB LED with an LM35 temperature sensor connected to an Arduino board to visualize temperature changes. The LM35 sensor outputs a voltage that corresponds to the ambient temperature. First, connect the LM35 to the Arduino. Connect the left pin to VCC 5V, the right pin to ground, and the middle pin to an analog input pin, such as A0. Next, connect the RGB LED. Connect the red, green, and blue pins to digital PWM pins on the Arduino, making sure to include current limiting resistors for each color. In the Arduino sketch, we will read the voltage from the LM35 and use it to control the RGB LED's color. For example, we can set the LED to red for high temperatures, green for moderate temperatures, and blue for low temperatures. This visual representation offers immediate feedback on the surrounding environment, effectively demonstrating the integration of sensors and actuators in a simple yet engaging manner. This setup provides a clear visual indicator of the current environment, showcasing the effective integration of the LM35 and RGB LED with the Arduino for interactive applications. In this automatic nightlight project, we will utilize a red LED and a phototransistor to create an ambient light responsive lighting system. The red LED is connected to pin 9 of the Arduino, allowing for pulse width modulation control, while the phototransistor serves as the light sensor connected to analog pin A0. In the code, we define light value thresholds, a minimum light value of 200 and a maximum of 900. When the ambient light level falls below the defined threshold, the red LED will automatically turn on, providing illumination in low light conditions. Conversely, when the light level exceeds this threshold, the LED will turn off, conserving energy. In this project, we will control a set of 10 LEDs using a potentiometer connected to an Arduino board. The primary goal is to create a visual output where the number of illuminated LEDs corresponds to the position of the potentiometer's knob, offering real-time feedback based on the potentiometer reading. The 10 LEDs are connected to pins 2 through 11 on the Arduino, and the potentiometer is connected to analog pin A0. The potentiometer acts as an adjustable voltage divider, outputting an analog signal that ranges from 0 to 1023, which the Arduino reads. Based on this reading, the Arduino calculates how many LEDs should be lit up, providing a smooth transition as the knob is turned. In the code, we start by defining the pins for the 10 LEDs and the potentiometer. We then continuously read the potentiometer value and use it to calculate the number of LEDs to illuminate. For instance, if the potentiometer is turned to its lowest position, no LEDs will light up, while turning it to the highest position will light all 10 LEDs. The potentiometer value is mapped to a range that corresponds to the number of LEDs, ensuring smooth and proportional control.